Okay, let's do a couple more examples. Example 3 says it asks us to do three things. It says find the average value of the function, then find the value of c where we achieve the average value of the function, and then do a sketch. So we kind of have done all of that in the first two examples combined. So here we got to do it all together, and then there's two different types of functions for us to do it. So let's just begin. Find the average value of the function. This is how you find it. So it's a continuous function that's differentiable over this, an integral. You can take the integral of it over this closed interval. So this is f average is going to equal to, sometimes I put AVG instead of AVE. The book has AVE, and I'm just going to use a G because I just am. So this is equal to 1 over b minus a, or 1 over 5 minus 2, the integral from 2 to 5 of x minus 3 squared dx. Okay, so this is all we got to do for part A, is do this integration. I'm going to use a u substitution. So in this case, I'll let u be x minus 3. If we let u be x minus 3, then du is dx. All right, so if we rewrite this integral, this is going to be 1/3. X minus 3 is my u, so this is going to be u squared, dx is du. Let's adjust our limits of integration. 2 minus 3, this turns into a negative 1. 5 minus 3, this turns into a 2. Let's integrate here. We have 1/3. This becomes u cubed over 3. We're going to evaluate it from negative 1 to 2. So basically, this is 1 over 9. U cubed is 2 cubed is 8, minus negative 1 to the third is negative 1, minus a negative 1. So basically, we get 1 over 9 is equal to 8 plus 1, which is 9, times 9, gives us 1. So the average value of the function in number 1 is, the answer is 1. Okay, now we have to find the value of c that gives us this. So we'll say c is equal to, or f of c, remember f of c is equal to the average value of the function. So f of c is equal to 1. And that is equal to this function at that value of c. So this is equal to c minus 3 squared. So now we're going to solve for c here. So basically, take the square root of both sides. So the square root of something squared is just the something, is equal to plus or minus the square root of 1, plus or minus 1. So if I solve for c, and if you want c on the left and plus or minus 1 on the right, you can do that. So c is going to equal to 3 plus or minus 1. And we get two values of c here. We get c plus 1, which is 4, c minus 1, which is 2. So we got two values of c. One is 2 and one is 4. And the last thing we need to do is sketch it. So let's sketch this and see what interpretation we get. This is not hard to sketch. This is a parabola that's being shifted to the right 3 units. So let's look at this guy. This is 1, 2, 3, 4, 5. Okay. So we've got this parabola here. All right. Oh no, that's too high. Here, here. Something like this. This is a sketch, right? Okay, so this is my parabola. Now, what did I just discover? Well, I discovered that there's two values of c that will fulfill the mean value theorem for integrals. And one happens when x is 2. Okay, this is 2. One happens when x is 4. So basically, these are the same y value right here. Okay. So between 2 and 5 is what my interval, so from between 2 and 5, there's two places, here and here. But this is the height of the rectangle. What does that mean? Well, that means that the area under the curve between 2 and 5, what would it be if we were just integrating? Well, the area under the curve between 2 and 5 would be like this area, right? So what it's saying is that this area right here is equivalent to that area right there, and the area under that rectangle is equal to the area under the curve. All right, that's the first example. Let's do the second one. Now we have a rational function, 1 over x. First, let's go ahead and do the sketch while we're at it. 1 over x, you know it's got a vertical asymptote at x is 0. If we just say at 1, it's up here at 1. This is 1, I made that too high. This is 1. At 2, it's at 1/2. At 3, it's at 1/3. So it is hugging the y-axis and kind of going like that. This is what it looks like. Okay, so this is 1, 2, 3. All right, so this right here is the area under the curve between 1 and 3. That's the integral. All right, so what do we have to do here? Find the average value of the function, the average height, basically. Okay, so right here, average value of the function is equal to 1 over 3 minus 1 times the integral from 1 to 3 of 1 over x dx. All right, the integral of 1 over x is the natural log of x. Use absolute values, right? The value from 1 to 3, it's 1/2 of this. All right, so it's 1/2 the natural log of 3 minus the natural log of 1. The natural log of 1 is 0, so it's really the natural log of 3 over 2. This is what, for example number 2, it's the natural log of 3 over 2. Now we need to find what two values, or no, I don't know that there's two values. What value is there? There is going to be a value of c. What is the value of c that fulfills this? Okay, so what we do for that is we say, well, this is the average value function, and so this is f of c, right? All right, so that's what f of c is. Now we say, okay, well, f of c is equal to, let's see here. Okay. F of c is equal to the natural log of 3 over 2. So, f of c would be 1 over c, right? So we say natural log of 3 over 2 is equal to 1 over c, because this is what f of c equals to. All right, if we're just solve for c, if you can cross multiply here, 2 is equal to c times the natural log of 3. C is going to be 2 over the natural log of 3. So this is our answer here. C, in this case, is equal to 2 over the natural log of 3. What did this equal to? The f average is what that equals to. Okay, now we have to do our sketch. We did our sketch. So where is 2 over the natural log of 3? Let me see. This is approximately, it's between 1 and 2. It's kind of like about right here. 1.78, something like that. If you put this in your calculator, I don't see mine close by, so I'm just going to go with this. It's about right here. And so this would be the height. This is f of c, right here. And so this is the rectangle that I would get. And what does this mean? It means that this little area right here is getting filled in right there. The fact that those don't look exactly like is fine because I'm doing a sketch, and that's just what it means. All right, let's do our last example. It says, in a certain city, the temperature in degree F, t hours after 9 a.m. was modeled by the function t of t is 50 plus 14 sine pi t over 12. Find the average temperature during that period from 9 a.m. to 9 p.m. So, if we need to find the average temperature, that is the average value, so we can do it. This is number 4. Goes like this. Okay. The function is, t of t is equal to 50 plus 14 sine of pi t over 12. Alrighty. Find the average value from 9 a.m. to 9 p.m. Okay, so here's the first thing we need to do. We need to normalize our data. Okay, so the time is t hours after 9 a.m. is when you normalize it. So that means when t is 0, we're at 9 a.m. Okay, and when t is 1, we're at 10 a.m. and so on. Okay, so when t is 12, we will be at 9 p.m. So that gives us the integral of integration. So we're going to go from 0 to 12, right? Is what we're doing. So this is going to be f average is going to be 1 over b minus a, or 1 over 12 minus 0, from 0 to 12 of 50 plus 14 sine of pi t over 12 dt. We just integrate this and we'll have the average value. So let's figure out the average temperature is what we're after this time. So 1 over 12 is equal to, let's see, I'm going to split up my integral. So I'll just put little braces there and it will distribute. Okay. So this is going to be the integral from 0 to 12 of 50 dt plus the integral from 0 to 12 of 14. I'm putting the 14 out here. The sine of pi t over 12 dt. All right. So then, let me get rid of this other function, which doesn't have anything to do with the one I'm doing now. So I'm not confused about that. Okay, so now, let's integrate 50 dt. That's just 50t, so that's no problem. Let's take care of him. That's going to be 50t. This is 1 over 12. 50t from 0 to 12. Okay, that's this guy, done. Okay, plus, let's deal with this guy. And we do u substitution, so I'll say u is pi t over 12. Let u be pi t over 12. Then du is going to be pi over 12 dt. So if I just need a dt, which I do, we can adjust it by the constant by dividing by pi over 12 or multiplying by 12 over pi. Du is dt. All right, that's good. Then when I want to integrate this part, this is 14 on the outside, the integral from 0 to 12. And I remember I have this other little thing, which is this guy right here. 14 integral from 0 to 12 of the sine of u. The sine of u. All right. And then du, or I need the dt, which is going to be 12 over pi du. All right, so I'm going to move my 12 over pi out here. So over pi times 12 is what I get right there. All right, that's fine. Let's integrate sine. What can you take the derivative of and get a positive sign? Nothing, but negative cosine, nothing directly. But the derivative of negative cosine would give you a positive sign. So we integrate this and we get negative cosine. So negative cosine of u from 0 to 12. Oh, very important. I did not adjust my limits to u. So that's let me fix that. Let's adjust the limits for u. All right, so what would happen here? 0 divided by 12 is 0. This is still going to be 0. Okay. 12. 12 divided by 12 is 1 times pi. All right, so that's going to be pi. All right, that's better. 0 to pi. What happened out here? I have 12 times 14 over pi, and it's negative. Okay, there's my negative. Okay, so let's evaluate this. 12 times 14 over pi, the cosine of pi minus the cosine of 0. All right, the cosine of pi is negative 1, minus the cosine of 0 is minus 1. All right, so this is 12 times 14 over pi times a negative 2. Somehow I think I'm supposed to get a positive 2 there. Let me see what I did wrong here. 14 over pi. 1 over 12. Oh, I haven't distributed my 1 over 12 yet.